Let's take another look at co-function identities. I know that sometimes when students look at co-function identities, they tend to treat them as if they are compound angle formulas or compound angle identities. And whereas you can use the compound angle identities, it's a lot easier to work with the co-function identities if you understand them. So let's see if we can develop them. First thing we want to do is we want to start with this right angle triangle. Remember that if it's a triangle, then all the angles have to add up to pi radians. Now, half of that, pi over 2, is in the right angle. So it means that these two have to sum to the remaining pi over 2. So if this is theta, and this is pi over 2 minus theta. On that basis, let's now see if we can develop sine, cosine, tangent, and cotangent ratios for this angle over here. Starting off with the sine. So sine of theta is obviously equal to opposite over hypotenuse, so b over a. Cosine of theta is equal to c over a, so adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent, which is b over c. And the cotangent is just the reverse of that. Just remember that cotangent is just simply the inverse of tangent. So if one is b over c, the other one is c over b. Let's now change our perspective. Not looking at this angle anymore. Let's look at this angle over here. So we're going to find the sine, cosine, tangent, and cotangent of this angle over here, the pi over 2 minus theta. Well, the sine of that angle would be c over a. It's opposite over hypotenuse. The cosine of that angle is equal to adjacent over hypotenuse, or b over a. The tangent of this angle is equal to c over b, opposite over adjacent, and the cotangent would be the inverse of that, b over c. All right, notice something. This is equal to b over a. This is also equal to b over a. That must mean that these two things must be equal, that the sine of theta must be equal to the cosine of pi over 2 minus theta. Similarly, this is c over a. This is also c over a. That means that these two things must be equal to each other. Similarly, this is c over b, that's c over b, this is b over c, and this is b over c. So these two guys have to be equal, and those two guys have to be equal as well. So we can set up some co-function identities right now. We can say that the sine of pi over 2 minus theta is equal to the cosine of theta. That's what this thing says right here. The sine of this is equal to the cosine of that. They're both equal to c over a. So that makes sense. The cosine of pi over 2 minus theta is equal to the sine of theta. That's what this says, that the cosine of this is equal to the sine of that. And of course, we said that the tangent of pi over 2 minus theta is equal to the cotangent of theta, and vice versa. Bear in mind that we should also be able to relate this to secant and cosecant. Because cosecant, remember, is the inverse of sine, so the cosecant of pi over 2 minus theta is equal to the secant of theta, because the inverse of that is equal to the inverse of this. Okay, so that means that that follows. Same thing for secant. The secant of pi over 2 minus theta, secant is the inverse of cosine, is equal to the cosecant of theta. Let's see if we can relate this now to the unit circle. Remember that this circle has rotations that start at 0 when you're right up against the x-axis, and they continue in an anti-clockwise direction. So this is pi over 2 here. This is pi. This is 3 pi over 2 down here. And then you can consider this to be 0 or 2 pi. Well, many times we talk about deviations from the x-axis. We're going to talk about deviations from the y-axis now. So here's my y-axis. So if I'm looking at a deviation from the y-axis, it means that this little part right here, this little deviation from the y-axis, is pi over 2 minus theta. Consider this to be the deviation that we're talking about. So if I'm looking at a deviation from the y-axis, it's pi over 2 minus theta. That's my quadrant 1 deviation. What about a quadrant 2 deviation? Over here, this is pi over 2 plus the deviation, or pi over 2 plus theta. If I'm in my quadrant 3, then I'm talking about 3 pi over 2 minus theta. And similarly in quadrant 4, it'll be 3 pi over 2 plus theta. That's my deviation from the y-axis, from the negative side of the y-axis. So let's go back and look at what we know about quadrant 1. Quadrant 1 we said was pi over 2 minus theta But bear in mind that all ratios are positive in quadrant 1. That's what this A stands for. In quadrant 2, it says that sine is positive. And remember, for quadrant 2 is pi over 2 plus theta. And sine is, of course, positive. In quadrant 3, which is the 3 pi over 2 minus theta, tangent is positive. That's what the T stands for here. And finally, in quadrant 4, we have 3 pi over 2 plus theta. Cosine is positive in quadrant 4. Now let's see if we can put all of this together along with what we started off with, which was the main cofunction identities. I'm going to repeat the first cofunction identities. In quadrant 1, we said that the sine of pi over 2 minus theta is equal to the cosine of theta. Cosine of pi over 2 minus theta is equal to sine theta. Tangent pi over 2 minus theta is equal to cotangent theta. And cotangent is equal to tangent. Now, all of those are positive because we're in the first quadrant. But things will change when we get to the second quadrant. We're still taking these deviations from the y-axis. This was a deviation in the first quadrant, pi over 2 minus. Now, if we're looking at quadrant 2, where it's pi over 2 plus, it still means that sine is equal to cosine, but because we're in the second quadrant, cosine is now minus sine. So it still changes from cosine to sine, but because it's the second quadrant, it's negative. Similarly, tangent becomes negative cotangent, and cotangent becomes negative tangent. All of these relate to the fact that sine is the only thing that's positive in the second quadrant. But I think you can kind of see where this is going for quadrant 3. In quadrant 3, the sine of that deviation is equal to minus cosine. The cosine is minus sine, but the tangent and the cotangent are both positive. So the tan of that deviation from the y-axis, 3 pi over 2 minus theta and 3 pi over 2 minus theta in both cases, is equal to the positive tangent. In quadrant 4, I'm almost sure you know where this is going. The sine of 3 pi over 2 plus theta, that's my fourth quadrant deviation now, is equal to minus cosine. Cosine is the only one that's positive, so the cosine of that deviation from the y-axis is sine. The tangent is negative, and the cotangent is also negative. Hopefully that helps you to see how cotangent identities can be applied in any quadrant and what sign the resulting cofunction identity will take. I thought we'd take a quick look at deviations from the x-axis as well. If you look at the diagram, you'll notice that I have a theta in the first quadrant, which represents a deviation from the x-axis. I'm taking that same deviation, that same theta, and I'm subtracting it from pi in the second quadrant. So here's my pi, and to get into that second quadrant, I'm minusing that deviation. To get to the fourth quadrant, I'm going to take pi plus that deviation. And for my fourth quadrant angle, the closest x-axis is here, so I'm going to take 2 pi minus that deviation. What now happens is the various sine, cosine, and tangent ratios will still be sine, cosine, and tangent. They're not switching like the cofunction identities, but they may change their sign, S-I-G-N. For instance, the sine in that second quadrant of pi minus theta is still sine of theta. The cosine of pi minus theta in that second quadrant, of course, would be minus cosine, and tangent would be minus tangent. So notice, not like the cofunction identities, the tan is not cotangent, it's still tan, but the sign will change, S-I-G-N will change. In quadrant 3, I think you can probably go from here. The sine of pi plus theta is equal to minus sine theta because sine is negative in that quadrant. Cosine is also negative, but tan becomes positive. I think you can probably take it from there for quadrant 4. In quadrant 4, you're going to be looking at the sine, cosine, and tangent of 2 pi minus theta, where in this quadrant, of course, cosine is positive. Hope that helps.